Hey, boys and girls, it's Mr. Mac. Today we're going to do Module 5, Lesson 3 for estimating volume. Now, when we hear estimating, usually we think we're going to be finding about the volume of something. Today, it's not really about the approximate or the estimate, really. It's just using kind of like everyday objects and figuring out what the volume is. Now, the reason that it's an estimate is because when you're stacking these things together, they're not taking up all total space, right? There might be little gaps here and there, like when you open up a box of something on the inside. Sometimes the things that are inside the box aren't stacked super tight, right? There's a little bit of wiggle room. So that's kind of why we're talking about estimating. But really, today's a big day of actually just finding volume again. In the example that we have here, it says Nicole is sending care packages to troops overseas. She places boxes of cards in the same size into the large boxes shown. Estimate how many boxes of cards she can place in the large box, and how do you know? Well, we're looking at these playing cards here, and we know that they give you this example where it says each playing card box is 2 centimeters tall. So if each box is 2 centimeters, and the box is 14 centimeters tall, how many rows can we stack on top of each other? Well, so 2 times what is going to give you 14. Okay, so that means 2 times 7 is going to be 14. So for this example, guys, we need to figure out how many playing cards are in each row, and we're actually going to have to multiply then by 8. Okay, I'm sorry, by 7. We're multiplying it by 7 because there's going to be 7 rows of these playing cards. I apologize for the mistake there. So to figure out how many playing cards there are, I'm going to get nice and close again to the screen here. And I see there's 1, 2, 3, 4, 5, 6, 7 going across in the row. And I go back and I count 1, 2, 3, 4, 5, 6. So 7 times 6 is 42. We take the length times the width, and that will tell us how much is in that base layer. So there's 42, okay? And then I would say 42, and there are going to be 7 rows. Each row is going to have 42 in them. So to find out the total amount of cards, I would do my multiplication problem, and I would get 294, which means that 294 boxes of cards can fit in this care package going overseas. So again, like I said, there's some wiggle room, so it's not exactly telling you the volume of inside of the box, but it kind of really is, right? So if we were talking about 294, that's how many playing cards we have, right? We're not necessarily talking about the volume of the box in this example, but we did use the idea of length and width and height to try and help us to figure out how many playing card boxes of cards, could fit inside of this care package. So when we move on to another example, which is very similar to this one, okay, Billy packs pasta boxes into one of 2 larger boxes for a local food bank. If she wants to pack at least 29 boxes in one of the larger boxes, which box should she use? So she needs at least 29. So we're looking for which one, box 1 or box 2 is going to give us 29 or more, because it is at least 29. So let's figure out how many are shown in the bottom layer of each. So we have 1, 2, 3 here, and it's 2 deep. So for this example, there are 6 on the bottom layer. And on this one, there's 1, 2, 3, and then 1, 2, 3. So there's 9 in the base layers of each, but just by counting each one of the base layers. So after we do that, if we want to figure out how many there are, again, we're doing kind of like a base, and we're multiplying it by the height, which is another formula for volume. There is 1, 2, 3, 4, 5. So for this one, we would say 6 times 5, which is going to give me 45. And in this one, there is 3. So we have 3 that we're going to multiply by, and that gives us 27. All right. Now, when we look at question B, though, when we're doing the estimating, it says, does knowing only how many pasta boxes are in the bottom layer of each larger box help you determine which box Billy should use? Okay. It can't just be the bottom layer that we know, because we don't know how many rows there are, right? If there was only 2 rows for each of these, then we could say, okay, well, now that we know the rows, we can figure out how many boxes there are. All right. But you can't just use the base to figure out the volume. You need the base and the height. How many rows are going to be stacked on top of each other? All right. So when the question asks in this one, what are the volumes? We just did that, 45 and 27. So which one should she use? She needs at least 29 pasta boxes, which means the only option that's going to work here is going to be box number 1, which had 45 pasta boxes in it. All right, if we want to look at one more example, I can do some erasing here, but it's still going to be the same type of problem where we're going to figure out how many are in a base layer and then multiply it by however many rows there are. So a company sends boxes of phones from its warehouse. The volume of each phone and its protective packaging is 12 cubic inches. So we know that the volume of each of these boxes is 12 cubic inches. So we want to figure out how many phones are all together. And then if we need to now know the volume after we have found how many phones there are, we can do that very easily. Okay. So the question is, how many are in the bottom layer? 1, 2, 3, 4, 5. And there are 1, 2, 3, 4 width. So there are 20 on that bottom layer there. Okay. Now there are 6 layers. So to find out how many phones there are, we're doing 20 times 6. That's going to give me 120. Okay. Now that means there's 120 boxes there. If I now needed to know the volume, well, the volume of one package is 12. I have 120 of them. So I'm going to take 120 and I'm going to multiply it by 12, which some of you may know a shortcut for this. I'm going to show the long way. 2 times 0 is 0. 2 times 2 is 4. 2 times 1 is 2. I put down my 0. 1 times 0 is 0. 1 times 2 is 2. 1 times 1 is 1. Okay, 0, 4, 4, and then 1. So the answer for this one, since we're talking about cubic inches, would be 1,440. We would say either cubic inches, okay, or we might say inches cubed with that little 3 there. As well. Okay, so again, this idea of estimating the volume, we first have to figure out how many objects we have. Okay, and then after we find out how many objects we have, we need to multiply that by the volume of one object. All right, so we're doing some investigating of these pictures to figure out how many objects there are, and then we're multiplying it by the volume of one of the boxes. Okay. All right. Hopefully this helps you with some estimating of our volume. Good luck with today's lesson. Take care. Stay safe, guys.